In this video, we're going to look at a couple of problems using recurrence relations. Now, a recurrence relation is where we have a sequence where the subsequent terms are based off the previous terms, such that u of n+1 is some function of un, or potentially un minus 1 and other previous terms in the sequence. They're quite usually a simple problem, and it's usually just a substitution to find subsequent terms. So the first problem says write down the first 7 terms of the sequence defined by un is equal to 3 times un minus 1 minus un minus 2, where u1 is equal to 1 and u2 is equal to 3. So we're already given the first 2 terms. We want to find the first 7. So after listing those, we need to list terms 3 through 7. And all we need to do is just substitute in. So we have our formula. So for the third term, we have 3 times u of n minus 1. Now, if we're at u3, u of n minus 1 is really u2. So we're multiplying by 3 minus u of n minus 2, which is equal to u1, and u1 is equal to 1. So then we multiply 3 times 3 is 9, minus 1 is equal to 8. For u4, we go back to the formula, and we have 3 times u of n minus 1, which is u3, and u3 is equal to 8, minus u of n minus 2, and n minus 2 gives us u2, and u2 is equal to 3. 3 times 8 is 24, take away 3, 21. Same idea for the next one, back to the formula. We have 3 as a multiplier of u of n minus 1, so in this case u4, minus u of n minus 2, which is u3, which is 8. 3 times 21 is 63, subtract 8 gets us 55. u6, back to the formula, 3 times u of n minus 1, or u5, which is 55, minus u of n minus 2, which is u4, which is 21. 3 times 55 is 165, minus 21 is 144. u7 then, so our final term, back to the formula, we have 3 times u of n minus 1, which is u6, which is 144, minus u of n minus 2, which is u5, which is 55. 3 times 144 is 432, minus 55 gets us 377. So those are our first 7 terms, and we can list them: 1, 3, 8, 21, 55, 144, 377. Moving on to problem 2 then, it says to write down the first 6 terms of the sequence defined by un equals un minus 1 squared plus 2 times un minus 2, where u1 equals 1, u2 is equal to 2. So we've got our first 2 terms. We want to write down the first 6, so we need terms 3 through 6. And again, we just need to substitute in. So we have u of n minus 1, which is u2, which is 2. We need to square that, plus 2 times u of n minus 2, which is u1, which is 1. 2 squared is 4, plus 2 times 1, which is 2, gets us 6. For u4, we have u of n minus 1, which is u3, which is 6. We need to square that, plus 2 times u of n minus 2, which is u2, which is 2. 6 squared is 36. 2 times 2 is 4. 36 plus 4, 40. u5, so u of n minus 1 gets us u4, which is 40, which we need to square, plus 2 times u of n minus 2, which is u3, or 6. 40 squared is 1,600. 2 times 6 is 12, which gets us 1,612. So finally for u6 then, u of n minus 1 is u5, so we've got 1,612 squared plus 2 times u of n minus 2, which is u4, which is 40. So at this point you definitely go to your calculator and you get 2,598,624. We've very quickly gone from 1 up to over 2.5 million in just 6 terms, and that can happen with recurrence relations, so keep your calculator at the ready. And that's how we deal with some simple recurrence relation problems.